Okay, I am on page 195 at example 1. And there's actually a graph that goes with this question, but I didn't take the time to draw that. I have just taken the points off that graph and put them on this table of values. So the first thing we want to do is determine if this is even a function. So if you look at the x column, first thing I notice is that these are consecutive values. They are in order, starting at 4 and ending at 9. And there are no duplicates in this list, so this is a function. The question is whether or not it's linear. So I can tell you by looking at this column, it is a function. I can tell you by looking at the y's that it is 1 to 1 because there are no duplicates in the y column either. So not only is it a function, it is a 1 to 1 function. But we need to decide if it's linear. Now, if I could see the function, I would know by looking at the exponent if it's linear. We could write one, we could get slope and go through that, but we want to use consecutive differences. Consecutive because it's in order, and difference because we're going to subtract. So I will bring the negative 1 up here, minus negative 2. And that is going to be a difference of positive 1. And then I'll bring the 0 up here, minus negative 2, 0 minus negative 1 is 1. It's looking like it's linear, but we need to check them all. You can't just do a couple and hope for the best. We need to check all of them. And we can check this one too. Okay, so then we have 1 subtract 0. That's a difference of 1. And then we have 2 subtract 1, a difference of 1. 3 subtract 2, a difference of 1. So this column tells me that the consecutive differences are common. That's important. But what's even more important is that they're common at the first level. That's what makes it a linear function. Because remember, quadratics and cubics, they can be common, but not at that first level. So the answer to this question, is it a linear function? Yes. How do I know? Because the consecutive difference is common at the first level. And just to contrast a little bit so your brain can see the opposite, let's look back at this example right here. This one was common, but it took us 1, 2, 3 levels to get that commonality. A linear function will be common at the first level. You don't have to keep going if it's a linear function.